Welcome again, guys. And this tutorial I'm going to teach you about gradient and equations of straight line. Now, gradient and equation of straight line, we are going to start right away with the definition of gradient. This one is something that is very common when we always come across it in our daily life. So the gradient is the degree in which something inclines. This one is just the degree. Is the degree. Degree goes with the angle in which something inclines. The degree in which something inclines. And when we talk about the degree in which something inclines, this one we are also referring to something called the slope. The slope. Now, example of an object getting inclined is the one I've just drawn on the board here. We got a ladder which is inclined against a wall at this particular angle. Let me call this angle here. Let me call this angle to be called angle alpha. So the ladder and the wall is making an angle alpha. So the degree in which this ladder is inclined against the wall, it is one which is called the gradient or the slope. Now, because the ladder makes an angle of alpha with the wall, and we also have another angle it makes with the ground. So this one, this wall here, in maths we call it the vertical line, and this one is representing the horizontal line, that is the ground. So the assumption in the finding of gradients when an object is inclined against the wall is that the wall and the ground makes an angle of 90 degrees at this particular point. So assume the angle at this particular point between the wall and the ground is 90 degrees now. Now, to find the gradient of this given object, we need to find the gradient. The gradient we can be given the length, the height of the wall, and the distance between the foot of the ladder and the wall and the foot of the wall. Between this particular point of the ladder and the wall. The distance between here, from this particular point here we have the red mark, this particular point to this particular point. So when I'm given the distance between the foot of the ladder and the foot of the wall and the height of the wall. So we need to find the gradient by finding the ratio. This one is obtained by finding the ratio of vertical distance. Ratio of vertical distance of vertical distance. Vertical distance is now the height. Vertical distance to horizontal distance. So this is how we find the gradient. The ratio of vertical distance, horizontal distance. So the gradient is vertical distance over horizontal distance. The vertical distance, when you consider the Cartesian plane, we have a Cartesian plane this way, got a Cartesian plane like this. So this one, the one that I'm putting around an arrow is the x-axis, represent the x-axis, and the vertical one represents the y-axis. Now when you want to find the gradient of a line passing through particular point on a Cartesian plane, it's not the ratio of change in y-axis. So change in y coordinates, so this gradient can also be obtained using the ratio of the change in y coordinates. Let me denote this as delta y, change in y coordinates, over delta x, change in the x coordinates. So that is when you are given points, 2 points where the line passes through on a Cartesian plane. Now let us find an example to do. find the gradient of the line. Now the example that you are going to perform are the one displayed on the screen. Find the gradient of the lines passing through the following sets of points. The first point is 3, 0 and 5, 6. The first set of points. So this 3 represents the x coordinate and 0 represents the y coordinate. This 5 represents the x coordinate and 6 represents the y coordinates. So the gradient of that given line is the ratio of delta y over delta x. So that is the change in y coordinate over the change in x coordinate. So if I call this 3, 0 becomes the first point x1, y1, and this one the second point, the second set of points become x2, y2. So I can say the gradient is the change in y coordinate. I say y2 minus y1 divided by x2 minus x1. So when I start with y2, I also start with x2. When I start with y1, I finish with y1, I also finish with x1. The same thing applies. You can start with y1 minus y2 over x1 minus x2. So the y2 is 6 minus y1, which is 0, over x2 here is 5 minus x1, which is a 3. So this is 6 by 2, and the answer we write here to be 3. So that is the gradient by 2, 1 by 2, 3. So the gradient is unitless. That is the first example. When you come to the second example again, I will come and say, let this first point be x1 and this one be y1, x coordinate, y coordinate. This one be x2 and this one be y2. So now again the gradient, find the gradient of the line passing at this particular point is a change in y over change in x, delta y over delta x. So y2 is 8 minus 5 over y1, 4 minus negative 3, x2 minus x1. So y2 minus y1, y2 is 8 and y1 here is 5. So that's what I've just subtracted. Then x2 is 4, x1 is negative 3. 4 minus negative. So 8 minus 5, we get 3 over 4 minus 3 is a 7. So this is the gradient of the second line. Coming to the third line here, number 3. So we call this one is x1, this one is y1, this one is x2, this one is y2. So the gradient equal to delta y over delta x. So this is my y2 minus y1 over x2 minus x1. So y2 here is an 8 minus y1 is a third divided by x2 is a quarter minus x1 is a half. So an 8 minus a third, you get a 5 over 24 over, that is the numerator, divided by negative a half. So it is negative 5 over 24, 5/24 over negative a half, and this also gets it to be 5 over 12. And that is the answer to the gradient of the third line, and it is very simple. So subscribe for more teaching videos and tutorials. You can also inbox me in WhatsApp via the email that I've just displayed on my bio. Thank you.